Okay, so we've seen that metal can be made to dissolve by reacting with the cation of another metal. That is a redox reaction where one metal ion oxidizes a neutral metal and makes that neutral metal dissolve. The next we're going to look at is the idea of a metal dissolving into another metal without changing its oxidation state. And this happens with mercury a lot and makes mixtures called amalgams. And that's an example of an alloy where one metal is dissolved into another metal. And we're going to do this using gallium, which we've seen already is good at making a liquid just above room temperature. So we have some gallium here, a small sample, that's in the liquid form. And what we're going to do is we're going to add three different metals to it. We're going to add some zinc, some magnesium, and some copper. And to make sure that we give it a chance, we've cleaned each of these by dipping them in acid to clear off any outer oxide layers. So I'm going to put the zinc in first, and now we'll add in the copper, and finally the magnesium. Okay, we're just going to let those sit for a few hours and see what happens, if anything. Okay, so we let our liquid gallium and the other metals sit for a while, and they actually solidified overnight. Now we've warmed it up again, so the gallium is liquid. And so now the real quick question, is have those other metals, ones that were submerged, dissolved into the gallium? So we're going to take them out and see if they have lost their bottom portions, and then also if it looks like they have, we'll pour out the gallium to see if there's any chunks of the original metals in them. So start the magnesium. The magnesium comes off, and it looks shorter than it was. It looked like it broke off. So it either broke off there, or it dissolved. And this is our copper wire. Copper wire looks like it's still all intact. So it looks like the copper wire has not dissolved. It's got some gallium coated on it, but it's not didn't dissolve. And next we have the zinc. I need my tongs. By the way, as an aside, look how ugly these tongs are now. They used to be really pretty. They got that way because I was using them near the nitric acid, and nitric acid corroded them. It's a little annoying, and I feel a little bad for the tongs. Okay, so we're going to go ahead and take out the zinc now. And it looks like the piece of zinc we had before coated with gallium. So it looks like these pieces of metal did not dissolve to an appreciable extent in the gallium. Okay, so it seems clear that neither the copper nor the zinc dissolved in the gallium, but the magnesium might have, because our magnesium ribbon, only the top part came out, and the part that was submerged didn't come out. So what we're going to do is we're going to pour the gallium into this dish here and see if we can see the copper ribbon there. We can see that it's pretty, that's for sure. Okay, so inside here, let's see if I can zoom that in. Can't see it in there. And we can't see it there. So we tentatively think that maybe the magnesium did dissolve into the gallium. I'm not sure, but that's what it looks like. Okay, so it seems clear that neither the copper nor the zinc dissolved in the gallium, but the magnesium might have, because our magnesium ribbon, only the top part came out, and the part that was submerged didn't come out. So what we're going to do is we're going to pour the gallium into this dish here and see if we can see the copper ribbon there. We can see that it's pretty, that's for sure. Okay, so inside here, let's see if I can zoom that in. Can't see it in there. And we can't see it there. So we tentatively think that maybe the magnesium did dissolve into the gallium. I'm not sure, but that's what it looks like.